that is step 2 is finding the finding initial feasible basic solution, right? So this is our next step, and in that very first method that we are going to see is, there are many methods, right? So yesterday we have seen there are many methods. So there is northwest corner method, you have row minima method, column minima method, least cost method, and WAM method, that is Vogel's approximation method. So today we are going to see the northwest corner method, northwest corner method, which is also called as it is NCWM. It is also called as NCWM. So basically now we will have to be very alert while drawing the table, and it is somewhat different than the previous table, right? So here, so we have 1, 2, 3, and 4 as our these destination centers. We have 3 plants with us, which are 1, 2, 3. We have this supply with us, right? So this is 6 million liters, 1 and 10 million liters. We also have demand with us, and demand is 7 million liters, 5 million liters, 3 million liters, and 2 million liters, right? So now the unit cost will be written in the upper corner. So this is the unit cost, what we have seen according to the matrix matrix terminology, right? Now what we have to do, now we are going to actually see how to allocate the values, right? Now these are the plants, right? So this plant number 1, you'll be seeing that the plant number 1 is able to supply 6 million liters of water, 6 million liters of milk. Plant 2 is supplying 1 million liter of milk, and plant 3 is able to supply 10 million liters of milk. Similarly, the distribution centers that we have, one distribution center is requiring 7 million liter of milk, second is requiring 5 million liter, third is requiring 3 million liters, and 4 is requiring 2 million liters. Now with all these constraints in mind, we are going to allocate these values, right? So according to the northwest corner method, what we are going to do is we are going to consider the northwest cell. So yesterday only we have seen this is north, south, east, and west, right? So the northwest direction we are going to consider, and according to this particular table, the northwest direction is this particular point, right? To cell 1, 1. Right, so this is the this particular cell. It is this particular cell is the northwest cell for this table, and we are going to allocate the maximum possible value in this step. Now you can see the plant 1 is able, so this is your plant 1, this plant 1 is able to supply 6 million liters of milk, right? And according to the distribution center 1, the distribution center 1 has it has the supply, or sorry, it has the demand of 7. So now for we are going to know this cell 1, 1 is with respect to plant 1 only, right? So cell 1 or entire your first row is with respect to your plant 1, right? And plant 1, the addition of the allocations of your plant 1 should not be more than 6, right? Similarly, your column 1 is is for your distribution center 1, and the addition of the allocations that we are going to do here should not be more than 7, right? Now what we are going to do is we are going to allocate maximum possible value in your northwest corner cell that we have selected, right? So now here you can see the northwest corner cell, what maximum value we can allocate here. We have the supply of we can do the supply of 6 by plant 1, and the demand is 7. So now which is particularly, if I supply 7 million liters, so maximum value, if you see, that is 7 value. But if I write 7 here, okay, for example, I'm writing 7 here, so what will happen is that this particular the constraint regarding your plant, it won't get satisfied, because 7 is greater than this 6 value, right? So what I'll be doing is I won't be allocating this 7 value. I'll be allocating 6 million liters here. When I allocate 6 million liters here, what will happen? The entire capacity of this plant 1 will get exhaust, and I'll be writing 0 here. That means that now I cannot do any allocation in these particular rows. So I'll be writing dash 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 in these particular cell. So the capacity of that plant has got exhausted because I have supplied 6 million liters of milk there, right? I'm hoping that you are understanding, right? So now entire your row 1 will get what? Your entire row 1 will get exhausted, and now you cannot consider row 1. Now we have which, we have this particular cells into consideration now, and these particular cells are into consideration. Right now, again, one more thing that we forgot to write. Now that I have put 6 in cell 1 no, I have also somewhat tried to compensate with the demand. So 7 minus 6, I still require 1 million liter of milk for my distribution center 1. So that is to be remembered. So both way, for supply and distribution, supply as well as demand, you should be updating how much milk is required. Right now, let's consider the row number. Let's consider next northwest cell, and the next northwest cell is your which cell? It is this cell 2 1. Right now, we have to allocate the maximum value here. Right now, here the distribution center 1 requires 1 million liter of milk, and again your supply from plant 1 is also 1. So the maximum value that I can allocate here is not more than 1, right? So if I go for 2, if I allocate value 2 here, what will happen is that the distribution center no the supplied value will be exceeding the plant capacity, and which is not right. So the maximum value that I can allocate here is 1. Now that I have allocated 1 here, what I have done is I have exhausted the supply for plant 2, right? And similarly, if you see the distribution center, so 1 million liter was pending, and now I have completely supplied the 7 million liters of milk. That is 6 plus this 6 plus 1 is equal to 7, right? So I cannot allocate any further values in this column. Similarly, I cannot allocate any values in this row also. Okay. Now next northwest corner cell that I have to identify. Now the northwest corner, the remaining cells that are with us is these cells, right? So all these cells are with us, and now we are going to find out these cells are available, and here we have to find out which is the northwest corner cell. So northwest corner cell happens to this particular cell, and now the allocation is to be done in this particular cell. Right now, the maximum amount of milk that I can the distribution center 2, requires, or it demands 5 million liters of milk, and again the plant number 3 is able to supply 10 million liters of milk. So the maximum value that I can allocate is what I can allocate. The maximum value that I can allocate is 5 here. So when I can't allocate 10 value because the demand is only of 5. So I can't allocate the larger values. I'll have to find out the maximum value that can be allocated. So if I allocate 5 here, so the entire demand for this distribution center will get exhausted. And here from 10, I have allocated 5. So 5 will be pending. Right now, next available cells are these two cells, and among this, this particular cell is the cell which is of the northwest corner cell. Now here the distribution center 3 has a demand of 3 million liters, and now I can supply and I am now with me I have 5 million liters also milk that is available, so I can supply all this year, and I can write 3 year. So now the pending milk million liter milk is 2, and lastly I can allocate it here, and this particularly finishes the allocation. Now you can see plant 1 has a capacity of 6 million liters, so we have allocated only 6 million liters of milk for this plant, and we have satisfied this constraint. Plant number 2 has 1 million liter of capacity, and we have supplied only 1 million liter here, right? Similarly, plant number 3 has a capacity of 10 million liters, and we have done we have supplied the milk 5 plus 3, 8 plus 2, that is 10 million liters, right? So for the constraints of plant we have satisfied. Let's check if we have taken into consideration the constraint of our distribution center as well. So the distribution center 1 requires 7 million liters of milk. So here 6 plus 1, so that is 6 plus 1 is equal to 7, right? So we have satisfied the constraint for distribution center 1. Similarly, here we require distribution center 2 require 5 million liters of milk. We have supplied this 5 million liters of milk. Distribution center 3 require 3 million liters of milk. We have supplied this 3 million liters of milk. Distribution center 4 requires 2 million liters of milk, and we have supplied this 2 million liters of milk, right? Now if we move ahead to find out what is the total cost of the transportation, so the total cost is equal to how much? So here it will be equal to, so this is 2 is the unit cost, right? So 2 into how much milk is supplied? We have supplied 6. 2 into 6 plus, right? Here we have unit cost as 1. So 1 into the supplied milk is 1 plus the unit cost is 8 here. 8 into 5 plus 15 is the unit cost. 15 into 3 plus 9 is the unit cost. 9 into 2. Addition of all this will be you'll be getting the answer as 116. So that means that the unit cost was given in hundreds. So the transportation cost that we required is 11,600. So the total cost of transportation that we required was 11,600. So this is the northwest corner method, and the initial feasible basic solution we have obtained with the help of this northwest corner. Again, coming back, let's come with another method now. So another method that we had was the row minima method, right? So row minima method, that we have. So again, I'll be the allocation that we have to do. So we have 4 distribution centers and 3 plants with us. 1, 2, 3. These are all the plants. These are the distribution centers. I will be writing it in the short form. So we have the unit cost as 2, 3, 11, 7. Next we have 1, 0, 6, 1. We have 5, 8, 15 and 9 as the unit cost. We have the demand as 7, 5, 3, 2, and we have the supply limits as 6, 1 and 10. So now firstly we have seen the row minima. Firstly we have seen the NS northwest corner method, in which the cell allocation was done in the northwest corner cell, right? So now here the name itself is given as the row minima method. So what we are going to do is we are going to go row wise, and the allocation that we are going to do will be in the in a particular row. If we consider the first row, we are going to do the allocation in a cell which is having the least unit cost, right? In every row we are going to repeat the same procedure, but you have to remember that you have, when you are considering any row, so let's say if you are considering row number 1, so you have to exhaust the capacity of that particular row, and then you will be marching towards the next row. So that is to be kept into consideration. So let's understand it with the help of this data set what we have, and then let's see if you have understood of this or not. So let's consider our row number 1, which is for our plant 1, right? So which is for our plant 1. So the supply that we'll have to provide is of 6 million liters. So again, irrespective of any method, we have to consider the constraints for your supply as well as the demand. So you can't if you're considering a row, so that doesn't mean that you are only going to look for supply constraints and you are going to neglect the demand constraints. So that is not done here, right? So we have to whether it is a column minima or row minima method that we are going to follow, the supply and the demand, both of these constraints should get satisfied. So let's try and see row minima method. So for our row 1, we have the plant under consideration is plant number 1, and the supply limit is 6, right? So the least cell, the cell with the least unit cost is which? This is 2, which is this is the cell, and here we are going to allocate the maximum maximum amount of quantity of the milk. So here while allocating the value, you have to see the row constraint as well as the column constraint. So here for the column for the row constraint we have 6 as a value, and here we have a 7 as a value. So no, we can't put 7 because that will be violating our supply constraint. So the maximum value that I can put here is the 6, right? So when I've put 6 value here, so I've exhausted the capacity of plant 1, and no, I won't be allocating any further values in this row, right? Similarly, I have to also update it here. So 7 minus 6, 1. So that is 1 is the 1 million liter milk is required in this particular thing, right? So we have considered the row number 1 and we have exhausted its capacity. So we are not going to do any allocation in row number 1 as of now. Now we have row number 2, and it is for plant number 2, which is having the supply limit as supply limit as 1 and supply limit as 1. Now while doing the allocation and considering this row, we have to identify the cell which is having the least transportation cost, and the cell which is having the least transportation cost in your row number 2 is 0, right? So we can do the maximum allocation that we will be doing maximum allocation that is possible. So for this particular cell, according to supply, I can go with the maximum value as 1, and according to the demand, I can go the maximum value as 5. But if I put 5 here, I'll be violating the constraint for supply. Hence, the value that I'll be putting here is 1, right? And we have exhausted the supply for your plant number 2. And even for that particular row as well, right? So there is no further allocation that I can do here. I'll be updating this particular demand, and I require 4 million liters milk for this distribution center 2 further. Right now, first 2 rows we have attended and we have exhausted the supply, and let's move towards our row number 3, which is for plant which is for your plant 3. So we have the supply constraint as 10, right? So the supply constraint is 10, and we have to also satisfy the various demand constraints for the distribution center. Yep. Now the least the least value with the transportation cost in this row is 5, right? So 5, the maximum allocation that I can do in 5 is 10 according to supply and 1 according to demand. So I particularly, if I put 10 value here, I'll be violating the demand constraint. So the value that I can allocate here should not be more than 1. So this particularly will be exhausting the this also will exhaust the demand for this distribution center, and I cannot allocate further in this distribution center. right? Nextly, in the next least cell, the next cell with the least cost of transportation is 8, right? After 5 it is 8, right? For 8 as well, no, okay, here we required the updation as well, so here I have to update this supply, which is now 9, right? So now the identified cell with the least cost is 8. We can supply 9 million liter milks according to the supply constraint, and no, the 4 million liters of milk according to the distribution center demand. So the value that I can put here is, right, it is 4, and this particular will be exhausting the demand of that particular distribution center, and I'll be updating it. So 9 minus 4 is your 5, right? Moving ahead, after 8, the next cell with the least cost is 9, right? And I'll be putting the values according to the supply and the demand here. So according to supply I can put 5, and according to demand I can put 2. But if I put 5 here, the demand constraint will get violated, and I cannot put value 5 here, so I will have to put the value 2 here, and the no supply of the demand gets exhausted, and I'm remaining with 3 million liters of milk, which I can put in the pending cell, which is cell with the unit cost 15, and this particularly finishes your numerical. Now you can check with the, if you have satisfied the supply and the demand constraints for plant 1. If you do, here we have only 6 million liters supplied, so 6, no, here the supply constraint is getting satisfied. For plant 2 we have supplied 1 million liter, so again the supply limit is getting satisfied. For plant number 3 we had supplied 1 plus 4 plus 3 plus 2 is equal to 10, and again our supply limit is getting satisfied. Similarly, we can check with the demands as well. So here for column number 1, 6 plus 1 is equal to 7, that is satisfied. Here we had supplied 1 plus 4, that is 5. So here again 1 plus 4 is 5, and again this is also getting satisfied. Here we have supplied 3, and the demand was also 3. Here we have supplied 2, and the demand was also 2. So what we can do ahead is, now we can find out what is the total transportation cost. The total transportation cost will be given by 2 into 6 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2. Addition of all this will fetch you the value as rupees 11,200, and that is, no, the value that you get is 112, and that is nothing but the demand value only, that is the 11,200. So if you check out the values of the transportation cost of with the northwest corner method and the minimum method, so you'll be seeing that the unit transport, the total transportation cost has reduced by rupees 400, right? So previously it was 11,600, and now here it is 11,200. So the unit transportation cost, that the total transportation cost got reduced by rupees 400, right? So the numerical is provided, right? Let's move ahead and again see our one more method, that is column minima method. In column minima method, similar way what we have seen in row, we'll have to repeat it for the, we will have to consider it for the column, right? So I'll be just drawing the table again. So these are all DCs that we have. We have plants 1, 2, 3. We have unit cost as 2, 3, 11, 7, 1, 0, 6, 1, 5, 8, 15, 9. We have the demand as 7, 5, 3, 2, and the supply as well that we have is 6, 1 and 10. So what we'll have to do is, now previously we we did it for row. Now we are going to consider the column, right? And when I say row, a row was specific to a plant or a source, and we were exhausting the capacity of that particular plant or a source. Now here in column, what we are going to consider is, a column is for a distribution center, or yeah, it is for distribution center or a destination. So when I say for a plant, so what we sorry, when I say for a column, it is for the destination, and we are going to satisfy all the demand. Previously it was regarding the supply, now here it is regarding the demand, right? So we are going to satisfy here, we are going to satisfy the demand for that particular column, and then only we are going to move to the another column, right? So now let's understand this with the help of this data set what we have. Now consider our first column. So again, what we did in row minima method was, we selected top row, and then we went to the bottom row. The same methodology should be followed. In column minima method, what we are going to do, we are going to consider the left column, and then we are going to move towards the right column. You shouldn't be taking any column or any row in between. The sequence of the rows and the sequence of the columns are to be followed, right? So let's continue this with the column minima method, and consider our first column, which is for distribution center 1. Now here the demand that we have is 7 here, and that demand we have to satisfy considering both the constraints, the supply constraints as well as the demand constraints. So now in this column, the least in column number 1, this particular column, the cell with the least unit transportation cost is this particular cell, which is having the unit transportation cost as 1. So we are going to allocate the maximum possible value for this particular cell. So the maximum possible allocation that I can do in this cell is either 1 or 7. So I can't put directly 7 here, because it will be violating the supply constraint. So here the value that I can put is 1, and that particular value is put. And this, after this, what will happen, I require more 6 million liters of milk here, but I have exhausted the supply demand here, and further I cannot put any values in this. I cannot put any values in this rows, right? So this is the so we have here what we have done is, we have exhausted the plant, but here we haven't exhausted the distribution center as of now, right? We still have 6 million liters of milk to be supplied to this distribution center. Now what we'll be doing is, we'll be identifying the cell which has again least cost in the same column. So we have done with cell 2-1. Now we are going to identify that particular cell which is having the least cost in the same column. So that particular cell is which? This particular cell, right? So here I have to allocate the maximum maximum milk here. So the milk that I can allocate here is, for supply constraint I have the value as 6, and for distribution for the demand I have the value as 6. So the value that I will be putting or allocating in this particular cell can be 6. So when I put value 6 here, so that I'm satisfying the supply limit here, and again I'm also satisfying the demand here, right? So particularly I'll have to put a dash, because the demand has got satisfied, and here also I'll have to post dash because the supply has got exhausted. So we'll have to work in the both way. I'll have to consider the supply constraint, demand constraint. In the same way, I'll have to keep updating the cells if the cells are getting exhausted by demand fulfillment, or they are getting exhausted by the for the supply constraint. So both of this updation is required, and it is easy, but you'll have to be alert in that particular case. Now let's move to the we have exhausted our demand for our column 1, and then only now we can move in for column 2. Right, in column 2 we have only one cell that is pending, so which is this particular cell, which has a unit cost of 8. Other cells like the unit cost 3 and 0 cells are previously exhausted, so I cannot consider any allocation here. So I'll have to do allocation with a cell which has a unit cost of transportation as 8, and what I'll have to do is now I'll be allocating here. So the maximum milk that I can allocate according to the supply limit is 10, and according to the demand is 5. So I'll have to put 5 here, and that will exhaust the demand of this particular column, and as well as I'll be updating it here as well. Right, now we'll have to move in column for column 3. Column 3, the previous 2 cells are already we can't put any value there. In the next cell we can put value which has a unit transportation cost as 15. Right, so the requirement is 3 and the supply I can do is of 5, so I'll be putting the maximum value that I can put here, and that is 3. And lastly I have this 2 million liters milk which is pending, which can be put here, and I will be exhausting the supply as well as the demand for entire the problem. So you can check with all this allocations what we have done, and we can see whether we have done the allocation right or wrong. Right, so if you see the supply and the demand, so I think all constraints we have considered here. 6 plus 1 is equal to 7. Here 5, 3 and 2. So all the distribution centers have been supplied the milk according to their demand. Again, the factories, here we have considered only 6 million liters, so here supply got exhausted. Here we have 1, so here it is also 1. Here 5 plus 3 is 8, 8 plus 2 is 10, and again this particular also got supplied. So what we can do next is we can find out the total transportation cost. Right, so the total transportation cost, if you find out, will be now what it will be 2 into 6 plus 1 into 1 plus 8 into 5 plus 15 into 3 plus 9 into 2. So the total transportation cost that you get is how much for this? It comes out to be 116. So that means that it is 11,600. Right, so this is the unit this is the total transportation cost that. Okay, yeah, right, so let's start with the least cost method. As the name suggests, what we are going to do in this method is that very simple method than all of these methods that we have seen, and I'll be writing down the numerical, the previous values of the numerical that we have. So we had 4 destination centers, or 4 distribution centers precisely. Four distribution centers, and we had 3 plants. Right, so the unit cost is known. We also know what are the supply constraints. We also know what are the demand constraints. Right, so 7, 5, 3 and 2. So this was the numerical that we have, and now with the least cost method we are going to allocate the values in these cells. So as the name suggests, least cost method, what we are going to do is we'll be identifying that cell which has the least cost of transportation from all these cells. So from all these cells, it is evident that this cell which is having the unit transportation cost as 0 is having the least cost. And what we are going to do is we are going to allocate maximum value in this particular cell. So now the supply constraint along this row is 1, and here we also have the distribution center constraint. Here it is 5. So the maximum value that we can allocate is the least value amongst this, and here we are going to allocate this particular value 1 year, so that exhausts this particular supply constraint or supply, and we are going to put a dash for this for these values. So again here we'll be updating. So 4 million liters of milk will be required for this distribution center. After 0, the next minimum value that we have is the next minimum value that we have is 2, right? So here we can't put the values in here, that is 1 and 1. So these were the least after 0, but these cells are already exhausted, so we are not going to put any values here. So if these cells were not exhausted, we would have put the values here. But again, if you see the the unit cost is 1 and 1, there is tie here. So how to solve this tie? So in this case, what we are going to do, we will be selecting that particular cell where we can allot the maximum value. So that particular cell is to be selected. Now, fortunately, we don't have a tie, and the next least value that we have is 2 here, right? So for this particular cell, we are going to allocate the maximum maximum possible value. So the supply constraint says that you have 6, the supply constraint has a value of 6, and the demand constraint has a value of 7. So here in this particular cell we can allocate the value of 6, and we will be exhausting this supply, and here also we'll have 1 million liter to be supplied as pending. So after every allocation, you'll have to see whether you have to update whether the supply constraints and the demand constraints are met, and also you have to update about all these cells as well. So now that we have supplied 6 million liters, so this particular cell will have to put a dash, so that we don't, okay, here we had made a mistake, so this is not exhausted as of now, right? So we'll have to allocate here, so some allocation need to be done here also, right? Okay, so next value what will have to after 2, the next least value that we have is which value? It is 5, right? So 5 here, so we have a demand constraint as 1 and the supply constraint as 10. So the minimum value among this we are going to supply, and that will exhaust this particular demand constraint, and here I will be updating it to be 9, right? After that, after 5, the next least value that we have is, which is the value? It is 8, right? So in 8, this particular cell we are going to do the allocation. So the maximum allocation that I can do in this cell is the values are 9 or 4, and the least value here is 4, and that I will be doing the allocation. So what will happen? This demand constraint will get exhausted, and here I have 5 million liters as pending, right? So even we'll have to update this cell as well, right? So no, by mistake I have written this value as 6, but this value is 3, right? So you can cross check, this value is 3 here, so this by mistake I have written it as to be 6. Yeah, so no, there is some mistake that I have made, so let's resolve this numerical again. Now let's consider this numerical, so there won't be any confusion. Okay, so the least cell is 0, so I'll be doing the allocation in the least cell. Here I'll be updating it as to be 1, so this will be getting exhausted. I can't put any values in this row, and I'll be updating this to be 4. After that, the least value that I have is 2. In 2, I'll be exhausting this particular, I'll be putting the value. The maximum value that I can put is 6. So I put the value as 6, and I have no completed this supply constraint as well. So I'll be putting dash 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 here, right? So again here I'll need to update. So the next least cell that I have is after 2 it would have been 3, but now the 3 we can't put any value in this particular cell, right? So the next least cell that I have is 5. So considering this 5 cell, so the maximum value that I can put here is 1. So I'll put this value as 1, and I'll be exhausting this. So the supply constraint value that I have remaining is 9. After that, what I can do is, after 5, the least cell that I have is 6, but 6 is already we can't put any value in 6. After that, the least value is 7. The 7 also we can't put anything. 8 is available for the for value. We can put the values in this particular cell 8. So what we are going to put the values here is 4. So here it will get exhaust, and here you'll be having 5 million liters as pending. After that, the after 8, the value that we have, least value that we have is 9. In 9, we are going to put the value as 2. So we'll be exhausting this as well, and we have 3 pending. 3 can be put here, and you will be having 0 pending here, right? We can find out the total transportation cost, and the total transportation cost that we have can be given as it will be given as 2 into 6 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2. So if you do all this addition, so you'll be getting it to be rupees 11,200. Okay, so this is how this least cost method is done. It is very easy to understand. No, and the name only it is already given that it is no. It will be these cells which have the least transportation cost will be used for the allocation purpose, right? So now a very important method that we are going to see is the Vogel's approximation method. So it is Vogel's approximation method that we are going to see, right? It is also called as VAM method. It is also called as it is also called as penalty method, and it is also called as regret method, right? So these are the names. In examination you may get a different name, and you shouldn't be getting confused that this isn't the part of the syllabus and this is the out of syllabus question. No, Vogel's approximation method, so the short form is VAM. You may also get no, you they may also call it as the penalty or the regret method. Now, this method, I want everyone's attention here, because this method is one of the most important method, and the quality of the basic feasible solution that we get through this method is is of a finest quality. And sometimes the solution that we get through the solution that we get from this is it is the optimal solution as well. So what we are going to do is now let's focus on this method. So initial part is same. We have the values here, 1 2 3 4 3, right? And let me write the value. 0 6 1, and it is 5 8 15 and 9, right? So we have demand as well, so which is 7532, and we have this supply as 61 and 10. Right. So now what we are going to do here is we are going to find out the penalty for each row and each column. Right. So hence it is also called as a penalty method. So what we are going to do is we are going to find out penalty for each row and each column. So now how to find out penalty? Now let's consider a row, right? So we are going to consider row 1. In row 1, which is the least value that we have, least value of the transportation cost that we have is 2, and the second least value that we have is 3. So your penalty is the second least value minus the least value, right? So here it is 3 minus 2, and you will be writing it in the form of bracket here, that is 1. Right. Similarly, for the second row, we have the least value as 0 and the other value as 1. So 1 minus 0 will give us the value as 1. Right. For the third row, we have the least value as 5 and the second least value as 8. So 8 minus 5 is 3. Right. Now we have done it for rows. Let repeat this step for the columns as well. In column we have, consider column number 1. In column, the least value we have 1 and the second least value that we have is 2. So 2 minus 1 will be 1. In the next column, the least value that we have is 0 and the second least value that we have is 3. So 3 minus 0 is 3. In the third column, the least value that we have is 6 and the other least value that we the second least value that we have is 11. So 11 minus 6 is 5. In the in the last column, fourth column, the least value that we have is 1 and the second least value that we have is 7. So 7 minus 1 is 6. Right. So these are the penalties of rows and columns that we have found out. Now amongst these penalties, the penalty with the highest penalty is to be considered. So for row we have 113 and for columns we have 1356. So amongst all this penalty value, the highest penalty value is for 6, right? And the highest penalty value is 6 and it is for your column number 4, right? So we'll be selecting now. We'll be doing the allocation in column number 4 only. Amongst this column number 4, we can do the allocation in 3 cells: 7, 1, and 9. Right. So we have this cell, and this cell for the allocation. So in which cell we are going to allocate? We are going to allocate we are going to do allocation in that cell which has the least value. Right. So least transportation cost. So the least transportation cost is 1 year, and we are going to do the allocation, maximum possible allocation in this particular cell. Right. So considering the demand and supply constraints, the maximum allocation that I can do here is 1, and after that what will happen? I'll be exhausting this particular row, and again I'll have to update the demand for this column as well. So when I'm exhausting this in regular fashion, I'll be putting a dash across all these cells because we can't allocate anything in these cells now. Right. Now after finishing of this particular step, we'll have to recalculate the penalties. So the recalculation of the penalties is to be done. Now the least values and the second least values have changed because now we are not going to consider this row number 2, right? Because it has been exhausted, right? So we are not going to consider row number 2 for finding out the penalties. Now in column number, let's find out the penalties for column number 1. So in column number 1, the least value that we have is 2 and the second least value we have is 5. So 5 minus 2 is 3. So now this is the penalty that we have got, and you can cross down the previous penalty to avoid the confusion as well. Okay. In the second column, the least value that we have is 3 and the second least value is 8. So 8 minus 3 is 5. We'll be writing out that penalty, and will be striking out the previous penalty. In the next column 3, the least value that we have is 11, and the second least value that we have is 15. So 15 minus 11 is 4, and we'll be striking out the previous penalty, right? In the last column 4, so in last column 4 also, there we can, this column is not exhausted. If it had been exhausted, we wouldn't have considered this column, but you can see still there is a demand of 1 liter here, right? So this column is not exhausted, so we can find out the penalty for this column as well. So it will be 9 minus 7, so it will be 2, and we are going to strike out this particular penalty, right? Similarly, for the rows, the row penalty won't be changing, but then also we can reconsider it. So it will be remaining 3 minus 2 only, right? So it will be 3 minus 2 only. The penalty value will be 1. The next for the next row now, this next row has exhausted, so we'll have to strike out this particular penalty, and this is not to be taken into consideration for the further calculation, right? So next last row that we have, the penalty can be calculated as 8 minus 5, and the penalty is 3 only, right? Now amongst this, all these new penalties, we have to identify the penalty with the highest number. So the penalty with the highest number that we have is which one? It is 5, right? And this particular, for this particular column now, we'll have to do the allocation. So when we consider this column, we can put the values in this cell and this cell. So which cell will have to consider? The cell with the least transportation cost, because our problem is itself is a minimization problem. So because of that, we are putting the values in the least cell only, right? So we'll be putting the value in the this particular column, sorry, this particular cell. So how much value can I put here? The value that I can put here is the demand is of 5, and the supply that is available is of 6. So I can put the value of 5 here, and I'll be exhausting this particular column, right? So when I'm exhausting this, I am going to put a dash here, and I'm going to update it here. So here, what is pending? Here we can still supply 1 million liter, right? So this row is not exhausted, but the column is exhausted. So as this column is exhausted, I can cut down this penalty as well, right? So recalculating the penalties again. So at after every allocation, you will be doing the recalculation of the penalties. So again, recalculating the penalties. So it will be 2 minus 5. So that is for a column 1. So it will be 2 minus 5 minus 2. It is 3. For column 2, now it has got exhausted, so no penalty will be considered. For column 3, it will be 15 minus 11. The penalty is 4. For column number 4, it will be 9 minus 7. The penalty is 2. Right? So recalculating the penalties for the rows as well. So if we recalculate the penalties for the rows, here the least value is 2, and now the second least value is 7. So 7 minus 2 will be giving me the penalty of 5, right? And again, row 2 we are not going to consider. In row 3, the penalty is the penalty remains. The penalty is going to change, and the penalty now here is 9 minus 5, and it is equal to 4. Right now, amongst all this, we are going to consider the penalty with the highest digit or highest value, and that penalty is 5. Right, so we have got this as the penalty. So for this penalty, what we are going to do, we are going to do the allocation. So the least value cell that we have for this row is 2. Okay, so the least value cell that we have here is 2. So previously, okay, yeah, so the least value cell we have is 2, and the allocation that we can do, yes, right. So the we have 5 across 5. This is the least value cell, that is 2, and we can do the allocation of 1 here. So you will be exhausting this particular row as well, and here the pending value will be of 6. So I'll be exhausting all this, and there is no need of consideration of this penalty further. right? Now we have exhausted two particularly what we can say is two rows are already exhausted. Let's do the allocation for the last row. Now in last row we know we can consider or we cannot, there is no need of consideration of the penalties, because here we'll have to just exhaust the values of this particular row. So there is no need of calculation of the penalties again for the last row. You can directly exhaust. So here you can see there is a need of 6 million liters. So I'll be providing the 6 million liters here. So here this will be done 0, and here you can see I'll be writing 4, right? So further if we move ahead, right, so further if we move ahead for this cell, that is this particular cell, we have the allocation of 3 to be done. So this 3 is done and this particular is getting updated, right? And lastly here is 1 0, and this will again turn out to be 0. Now let's calculate what is the total transportation cost for this. Total transportation cost. So if we calculate the total transportation cost, so it will be 2 into 1 plus 3 into 5 plus 1 into 1 plus 5 into 6 plus 15 into 3 plus 9 into 1. So if you do all this addition, the total cost that we get is rupees 10,200, right? So now just for your understanding, total transportation cost. We have calculated the total transportation cost for northwest corner method, and it came out to be 11,600. We have done it for a row minima method, RMM. I will be writing the short form. It came out to be 11,200. For column minima method we did, and it came out to be 11,600. For least cost cell we did, and for least cost cell we got the value as 11,200, and for VAM that we did, we got the value as 10,200. So now you will be seeing, I initially told that the quality of the solution that will be obtaining through through your VAM method is of superior quality. So you can see that we have got the total transportation cost as rupees 10,200.